find. Hello, welcome to the last talk at the conference. So a lot of the time I do these last talks at the conference thing and they're like the worst programming language ever or programming's greatest mistakes and they're hilarious and everyone laughs. This isn't that. This is actually sort of technical and sort of opinion-based. I hesitate to use the phrase opinion-based because that suggests that I'm not necessarily right, and I definitely am. And the title, You're Doing It Wrong, it's possible that you're not doing it wrong. You might be doing exactly what I'm going to talk about here, in which case you're doing it right. And you can go back to your company and say, well, we are doing it right. Mark Rendle agrees with me. And they will have no option but to say, who the hell is Mark Rendle? So yes. So anyway, I'm hoping I'm going to maybe change a few people's minds. This is an entrenched thing that I'm going to be talking about. And you got to start somewhere. So I'm starting here, and then they'll put it on YouTube. Hello, YouTube, cheapskates. And there we go, there's some negative comments already. And yeah, so let's crack on with it anyway. So, OpenAPI. I've lost my monitor. So I'm going to have to turn around and look at the slides, which is very unprofessional until the monitor comes back. So yes, right, let's go back to that one because it's there. So what is it? Obligatory Red Dwarf quote, because I'm old. If you haven't seen Red Dwarf, it's probably on one of the streaming services like BritBox or something like that, so check it out. But no, so OpenAPI is a structured data format for describing APIs. And it was started as Swagger. And Swagger was kind of like an independent thing. It was just pushed by this one company. And then Swagger became OpenAPI 2.0. And it had some deficiencies and everything, so they used that as the bouncing off point, and then they came up with version 3.0, which is the current version of OpenAPI. And there is a slightly newer version called 3.1, which has got a few changes and usability enhancements over 3.0. And then there's a 4.0 kind of out there prospective ideas for the next version project, which I'll talk about a little bit at the end. But use this one. Oh yeah, no, I remember this from the last time I gave this talk. I forgot to turn off the animations on my copied and pasted slide. If you've seen Programming's Greatest Mistakes, you'll know how many of those are copy and paste problems. So yes, the one you should be using at the moment is 3.0. 3.1, lovely, new and improved, not very well supported by editors, and all the tooling and all that sort of stuff doesn't really support it properly yet. So I suspect all of that will catch up just as 4.0 gets released and everyone wants to use that. So the implementation, it kind of flickers up on here and then it disappears again. I think we killed it last night. So yes, the implementation of OpenAPI, this is the thing I really want to talk about, okay? Because NDC, most people come to NDC conferences are .NET developers. Sometimes you get Java developers who thought it was a go-to and they've just got terribly, terribly lost and they have to watch all these talks about the superior technology. But so I'm assuming most people here are building APIs in .NET, hopefully .NET 6, maybe .NET 7 if you work for one of those companies that goes, yeah, no, it's fine, we'll use the current release, we don't need LTS. And when you do OpenAPI, what people think of as OpenAPI in .NET is Swashbuckle or NSwag. And Swashbuckle, actually, if you do .NET New Web API now, it dumps Swashbuckle in there for you. And the way that you add OpenAPI to your project is this. You have your controller action method that returns an action result, and it has a parameter from body add book, which is your model that you're using to serialize as JSON and pass up there. And without any of these attributes, you can sort of produce a barely usable SwaggerUI page that will sort of go, well, there's a thing and it's called this and the path is this and it takes these parameters. Other than that, I have no idea. And so you want it to be sort of more descriptive. And so you add all these parameters. You go produces response type. So all the different responses the thing can produce, you document them in attributes. I have, at the place where I'm currently working, where they're very big into, there should be proper OpenAPI documentation for all the APIs, and there are a lot of APIs. And 3 or 4 lines of code, so get something by the ID, and it's like we got an injected Cosmos repository, so we get it, and then we return it. It's like 3 lines of code. And then 15 lines of attributes to try and get the OpenAPI documentation to work properly. That's how we do it in .NET. That's how we have been raised by Microsoft to expect things to work. This kind of, Microsoft have a history of this. ASP.NET, the original ASP.NET web forms, the whole point of that was that it looked a lot like Windows forms. So people who had been using Visual Basic to build Windows applications could switch over to using either VB.NET or C# to produce web applications, but they could pretend that they were still building desktop applications. So they said on-click on a button, and it completely hid the fact that that was doing a round trip to the server and doing magic and then chucking it back down there with a megabyte of view state to make it work. And then there was .NET remoting, and then that got replaced by WCF, which supported SOAP as the hot new thing in 2006. Time is just going so fast now. And with WCF, you basically built your interface, and you put service contract and data contract and operation contract on stuff, and it generated the SOAP XML file. And you're kind of like, fair enough, actually, because the WSDL files that it nobody wanted to write those by hand. But everybody else in the entire tech industry, when they want to do OpenAPI, they open a text editor and they edit the OpenAPI.YAML file. And they put the information in there, and then they build the API to match that specification. And actually, you can get code generators that will generate you a basic Node.js, Express.js application based on your OpenAPI specification. It's only in .NET that we do this thing the wrong way round. And I'm going to argue that everybody else is doing it right, and we are doing it wrong, and that handcrafted artisanal YAML files are what we should be using, just like everybody else. And the thing that triggered this for me, so the place where I'm working at the moment, very, very API heavy, very microservices, lots of things running in Azure functions, way too many nano services, actually. We need to sort of collapse some of those nano services into just microservices. And every one of these APIs, they have a GitHub repo. And they've got the Swashbuckle in there. They've got the Swashbuckle plugin to make it work with Azure functions. And it works. It generates the SwaggerUI page, and you can try things out and all that sort of stuff. And then in the GitHub repo, they've got an API.md Markdown file, which is hand-maintained, which documents the API, so that you can go to GitHub. And I was looking at this, and it's kind of hash, hash, and then the path, and then hash, 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 get, and then a quick description line, and then a code sample with a kind of, this is the schema for the object, and a dotted lists and nested lists and all this sort of stuff. And I'm kind of like, you're recreating OpenAPI YAML in Markdown. So you're still having to hand maintain this thing because you want the information in your GitHub repository, but you're not just using the thing that's already out there and has editor support and standards and linters and IntelliSense and all these kinds of things. You're just recreating that ad hoc in Markdown. Why are we doing that? And so hence this talk. Because, YAML, you can write your OpenAPI specification in JSON if you don't mind wearing out your Shift 2 keys on your keyboard with all the double quotes, unless you're American, in which case it's kind of somewhere over by the return key. Oh, I don't know, anyway. But yes, people kind of say, oh, I hate YAML. YAML is the worst serialization format. YAML is the worst structured data format. And I would argue that, yes, YAML is the worst structured data format, except for all the others. It's basically JSON without the double quotes and curly braces all over the place. Yes, it suffers from the same thing that Python can suffer from, which is when some idiot checks it out into an editor with tabs instead of spaces, they will break everything. But if you want to do anything these days, you're editing YAML files. If you're going to have GitHub actions to do builds, if you're going to run things in Kubernetes, if you're going to do any of this sort of DevOps stuff or CI/CD stuff, you've got YAML files in there somewhere. So just accept it. Someone at some point will come up with something better or a better way of editing YAML files. But for the time being, let's just deal with it. Back in the day, so I've been doing this for a very long time. I have been doing professional software development since I was 17 years old, which was 1990. And when I first started, and I went out contracting, and I was writing software in Infomix 4GL on Unix systems, and it was full waterfall. There was a thing called SSADM, which was a kind of design and implementation methodology, and Prince2 as well. And you weren't allowed to write a line of code until somebody had given you a specification that detailed every single line of code that you were supposed to write. And you were just kind of, so you're translating some business analyst's description of the system line by line into C or Infomix 4GL or whatever the language was. And at the time, we used to say, why can't we just have specs that compile? Or even specs that can be validated, specs that you could lint and say, does this spec make sense? Does it have all the information that is needed? And now we have OpenAPI.YAML, and for API specs, that's exactly what that is. It is a standard. You can lint it, you can IntelliSense it, you can do all this sort of stuff, and we're getting to the point where you can just compile it, and it will become a working application. So, why? Why do you want us to edit YAML files by hand? Why do you hate us? This is the key thing. So, if you are the only person working on an API, then this argument holds less weight because, it's just you and you're noodling away at the thing and it's fine, just use Swagger and Swashbuckle or NSwag or whatever. But as soon as you have 2 people or 3 people or 4 people working on the same project and you're building sort of, this guy's doing that controller and that girl's doing the other controller and whatever else is going on, you need to have a source of truth. You need to go, this is the schema for the user object. This is the schema for the product object. And this is the format that URLs will take, and this is the standard that we're going to use for error reporting in JSON objects and that sort of thing. And at that point, you want a design document and you want some standards in your project. And yeah, you could do Markdown files, you could maintain a Word document, you could put it wherever you want to do it. But OpenAPI is right there saying, hello, I am the accepted, standardized, shared, widely understood, supported by tools way of doing this. Please use me. You create an OpenAPI.yaml file, you put it into your source code repository, somebody wants to change the specification, they open a pull request. Yeah, you can't open a pull request on a page in Confluence if you have to use Confluence. And if you have to use Confluence, I am going to, at some point, get NDC to let me set up a booth where people who have to use Atlassian software in their jobs can come and get a hug. Can't do completely no jokes. You know, it's Atlassian. But yes, Confluence, specs in Confluence pages. Someone comes along and changes it. There's no review process. There's no what about this and so forth. OpenAPI.yaml file. Git merge can cope with it really nicely because it's structured. Git merge kind of understands structured things. And it can go through a review. It can go through people nitpicking on things and everything else. So it becomes that single source of truth for your team. It separates the design and the implementation. And there's that famous saying that with 6 weeks of coding, you can save yourself literally 6 hours of design time. But sitting around a whiteboard, and I'm actually, I think its first time is going to be at NDC Oslo. I have a new 2-day workshop on designing and implementing APIs. And it starts off with the whiteboard and going, okay, so this is the API. It's interesting because it's going to be a different workshop every time because I'm not going to tell them what's right. It's just idea storming at the start and saying, oh, so we have this object and that object. But you start around a whiteboard and you design it and you show the links and the ways of getting from this place to that place and all this sort of stuff. But when it comes time to write that down into a form that then becomes the driver for the project, you codify it as OpenAPI. And then you've got your OpenAPI.yaml file in your repository, and you work on the code until what happens matches what the spec says. You have this idea of separate design and implementation. It's a better description of your API. So I'm going to show you some of the stuff that you can stick into these YAML files if you handcraft them artisanally, and getting them into Swashbuckle or NSwag, it's possible, but some of the ways you have to do it are really, really disgusting. There's like callbacks and assembly attributes and all sorts of mad stuff in there, whereas you can just type it in. You can put Markdown in some of the sections, and the renderers will nicely format that for you with bold sections and code syntax highlighted sections and everything. So you actually have a better, a human-focused description of your API rather than what the machine generates. And finally, and I'll show you a couple of examples of this, you have automated documentation. So as far as most .NET developers are concerned, the documentation is SwaggerUI. SwaggerUI is not documentation. It's a hack it and try it interface, but it's not documentation. You can produce actual static documentation, which you can include in your GitHub repository. So your application doesn't even need to be running for somebody to learn how to use it. Imagine that. This is not OpenAPI. This is protobuf. Protobuf and gRPC, which is another thing that I'm quite hot on, you define your messages and you define your services in the protobuf language, and then you compile that with Proto-C, and it generates the classes and the stubs for the services, and then you override things and you implement it and everything else. And again, in .NET, there are multiple ways of doing this. So Mark Gravel, who is an extremely talented developer who I have an enormous amount of respect for, has a code-first way of doing both protobuf and gRPC. You create C# code and you annotate it with attributes, and it generates the proto file at runtime. But the other way of doing it is to write the proto file and then use the official gRPC.NET libraries to generate those base classes. And the difference is that by doing that, you can get a file that you're sharing with your users, which is how they create their client to interact with your service, but also has all this, it has comments. This is the other reason why YAML is a superior format to JSON, because YAML supports comments and JSON doesn't. So when you go to use the money type from Google APIs, you don't have to go, well, what's units and nanos? What does that mean? Because there's comments in the proto file to explain to you how that works. So let's start looking at OpenAPI, because this is the other thing that I've noticed is it's generated for us. So you look at, you go to /swagger and you get the UI thing comes up. Quite a lot of .NET developers who've probably been using this stuff for years now actually have no idea what OpenAPI itself looks like. They don't know, they've never looked at it. They just look at Swagger and they go, that's it, that's what OpenAPI is. So let's actually dig into what you've got in here. So at the top, I say this is an OpenAPI file, and this is version 3.0.0, at which point Visual Studio Code kicks the OpenAPI extensions that I have installed, and they come to life and start putting red squiggles under everything because I've done it wrong. So I use that as my top level thing. And then I have this info section. Getting this info section in using NSwag or Swashbuckle is challenging. It's no obvious way of doing it. And so I have a title for my API, and I tell you which version it is. And then I put contact information in there because I'm nice, and if you have problems with my API, I want you to be able to contact me. We're in a fantasy world here, okay? So let's just go with it and imagine that I'm that kind of person. So it's got my name and my email and a URL where you can find out more. And then we have tags. We can tag things, and things can have more than one tag. And if I have this tag section at the top here, I can add additional information to the tags, like descriptions and so forth. And then all I have to do is reference that tag elsewhere in the document, and all that information will come with it. And then we have paths. And we declare, so we have a paths section in our YAML file. And then beneath that, we have a series of objects, each of which is the property name for it is a path. So here it's /read /read/books. English, yay! That's quite obviously read and not read, okay? So just we know. And then below that, you have operations, and you have get, and then you have an operation ID that gives it a nice name, which will display somewhere very nice. And then you have a summary of what this is. Summary, this is one of those. So anything that says description or summary, you can use YAML's sort of multi-line text feature, and you can dump Markdown in there, and that will render nicely into various user interfaces. I say this is part of the books section. This is got the tag books on here. And then I have a responses section. And I say, okay, this could respond with a 200, and the description of that would be okay. And I can provide more information in there as well. So I can say that 200 okay, it'll have some content, and when the content is application JSON, then it will adhere to this JSON schema, and I can reference that, and I can declare that at the end of my YAML file, and then reuse that declaration all over the place. And I can put examples in there as well. So you'll see the schema bit. This is what it looks like. You'll see in SwaggerUI if you're using Swashbuckle or NSwag. But the examples, if you have something that can generate them, they'll be complete nonsense. If you hand code them, you can actually go, you know, this is a proper example of what this might look like. Schema. This is an interesting point. So there's a very good way of describing the structure and types of JSON documents called JSON schema. And so, of course, OpenAPI supports JSON schema. Almost. It doesn't. It mostly supports it, but there's a bunch of things that you can do in JSON schema that OpenAPI completely ignores, and there's a couple of things you can do in OpenAPI schema that a JSON schema validator will chuck a fit at. So yes, But you can essentially describe your object. You go, it's application JSON, it's an object, it's got an ID property, a title property, a finished app property, which is a string, but it's got the format datetime because JavaScript and JSON don't know what a date is. And so you can put this information in there as well. You can describe the parameters. So we can say, so we have read/book/ID, so you can get a specific book that you've read from my done.dat API. All these examples come from a thing that I'm kind of building as an example project for this called done.dat, because A, everybody does to-do lists, and B, to-do lists are really stressful. It's just more psychic weight that I don't need bearing down on me. So I'm building a done list. Once I've done something, I'll go, I've done it. That's it. It's fine. I read it. I did a run. I played a song, whatever it might be. So yes, anyway, we've got a little squiggly ID thing up in there, and then down here we can say, oh, there's a parameter, it's called ID, it's in the path, you could put in query or in header in there as well, and then we've got a schema, and its type is string, so we know that it's a string format, so you could put integer in there or float or whatever, and you can say it's required, so people know that you have to put that in there, because otherwise you'll just get the other endpoint. And we can describe requests as well in much the same way. So if we say, I want to say I covered a distance, then we can, I really need to check my examples. So we go, yes, this is for measuring runs or bike rides or walks or whatever you might be doing. And so when you want to say, oh, I covered a distance, then you need to specify a request body that includes the author and the title of the distance that you covered. That should actually be how far was it, what units is that in, and what were you doing, running, cycling, or walking. But never mind. I edited half of it and not the other half. Never mind. Anyway, but yes, so you can specify what your request should look like as well. So doing that all the way, if you have to copy and paste that schema and into everything that's returning a book or everything that's adding or updating a distance or anything like that, then you're going to end up with the kind of copy and paste mistakes that end up with distances having authors and titles, and you don't want that. So what you want is a sort of shared area where you can declare reusable components. And so there's a components section in an OpenAPI spec. And in there, you can put schemas, responses, request bodies, parameters, headers, security schemes, examples, links, and callbacks. And so all of these things, when you've got a location header, which is going to have a URL in it, you can just create a component under headers that says location or created or whatever you want to call it. And then you can just reference that from wherever. When you've got a sort of standard object to represent some data, you put that into schemas, and then when you've got a 200 response that returns that object from various different places, you can create a standard response and then reference that rather than writing out response, content, schema, and everything else. So you can reuse things like this. And it's incredibly easy. You just have components, schemas, book, and then you declare what that schema is. And the same thing with responses and examples and everything else. And then you can refer to those as #/components and just drag them into other places in the spec. And OpenAPI parsers will take care of rehydrating that and doing all that funky cool stuff. You can also have references to external files. And so you can have a directory of schema in your OpenAPI folder, and in there you can have book.yaml, and you can have an examples directory, and you can have examples.yaml, and you can reference these things. The issue with doing this is that you need to bundle it into a single YAML or JSON file for publishing, because things like SwaggerUI and various other things will not follow those links as a rule. But there is a bundler, and I'm writing another one, because why would I let the fact that there already is one stop me from writing my own? It's not written in .NET is the simple answer for that. I'm going to release a whole bunch of stuff where you type .NET space, OpenAPI space, and then magic things. So yes, and we have security. I'm just going to stop because I've just remembered that I have code that I can share with you. So let's take a look at some of this in actual practice. So yeah, here is my YAML file. I'm going to make that a little bit bigger. Is that all right for people at the back? Yay! Yes, says someone 2 rows back. So yeah, this is a full OpenAPI file. I'm just going to make that go there. So I've got my info there. I've got tags, and each of my tags have descriptions attached to them. I've got a security section where I'm saying auth0, and that's an empty array. This is a really weird thing that I learned about YAML while I was figuring out how to do this stuff. If you just want a property name, then in an array of objects, you have to put in a property name and then an empty array, which is going, just use this thing. But yeah, and then I have my paths, and I've got read books, and that has a get, and you can do get books, and it returns a list of completed books, which refers to schemas, list of books, and it has an examples thing there. And we have a post operation to add a book, and you can see here that that uses the new book schema, but the example is just the title would be Hitchhiker's Guide to the Galaxy, and the author would be Douglas Adams. And then we have a 201 response, which returns a 201 created response, and a 400 response, which returns a bad request. And those are external. So if I go over here to responses, and I can go to 201 created, and so the description of this is record created, and it's not going to have any content because you shouldn't. Post operations really shouldn't return the object you've just created. They should return a URL so you know how to get it. And so that's going to return a location header, which is declared yet somewhere else. And here we have a location.yaml, which is the absolute URI of the created record, and the type would be string. I'm pretty sure I could put format. Nope, I can't. Never mind. So yeah. So going back to here, we've got various other things. We've got examples. We've got a Hitchhiker's Guide to the Galaxy example and a Mort example. We've got distances, where we can go down to the bottom and see that. We also have users. We've got an operation initialize user there. Here we've got our examples, and our schemas are all declared, and we've got a list of books. So when we have a list of something, we can just say the type of this is array and the items, and then we refer over to the book that we've already previously created. Distance down here, yeah, there we go, that's more like it. ID, kilometers, and type. New distance, kilometers, and type. So the new objects are generally the same as the sort of actual objects, just -1 property. It is possible to do inheritance, sort of, with JSON schema. So you can declare the new object and then inherit the object with the ID property from it and just add the ID property. But it's really ugly, and I hate it, and so I don't like doing it. But for the distance type, we say, OK, this is a string, but it's also an enum, so it can only be one of these 3 values. So when someone comes along and generates a client, it will actually generate an enumeration for that property. So when people pass it in, they get to choose it from a list of constants or an enum in TypeScript or whatever it might be. And then down at the bottom here, we have security schemes. And we can say, yeah, so this has auth0, which is OAuth2 with an implicit flow using this authorization URL and this scope, or you can use client credentials, and there's a token URL at that endpoint there. So client credentials for your desktop applications, implicit flow for saying, Scott Helm be damned, I'm breaking OAuth, and I know I am. OK. So yes, that was the security bit. You can specify your security in there. The other thing is problems. So it's no longer enough just to return a 400 error and go, that was a bad request. That's just incredibly mean to say, you sent me a request, but it was bad, and so I'm refusing to serve it. It really helps if you send that person a little bit of information about what exactly was wrong with their request. Did they try and pass a big number into a UUID field, or was a value completely missing? And so there's a standard now, which actually has its own MIME type, application/problem plus JSON, which you can return back, and it's got a sort of what the error was and where the error occurred, and it will handle multiple errors, and it will tell you everything that was wrong with your thing. An ASP.NET Core will actually generate that for you from the model binding. So if the model binding fails because of the required attributes or the regex attributes or anything else, it will just give you that as a problem object, and you can return it back out. I'm fine with that, by the way. I have no desire for people to start manually writing their own model binding, maybe next year. This is roughly what it looks like. So we have the type is a string and the title is a string, detail, status, instance. Errors is an object. It's not an array, it's an object, so each error has its own thing, and then you've got sub-errors in there. And then you can have extensions, which means you can put anything you like in there. That's forward compatibility. And then we can specify the example here and tell it what the type is. Type would normally be a URL saying this is the type of error, and then you can click on that and it'll go, yeah, this is exactly what you did wrong and why it's a bad thing according to the IETF. Title, one or more validation errors occurred. Trace ID, so that people can link it to their logging system or their distributed tracing system or OpenTelemetry or whatever it might be, and other cool stuff. So yeah. So before I go any further, I want to show you some of the really cool stuff that this enables, if I can find my thing here. Right. This is the repo with all the code, so the Done.dat API, and a really crappy front end for it because I am not a front end person, but you know, it works. And this has got the Done.dat folder is there, and in the Done.dat folder, there's the API, that's the solution with the back end in it, and I've got a front end, cleverly named solution, which has got that in there, and I've got an OpenAPI folder. And in my OpenAPI folder, I've got my OpenAPI.yaml file and responses and headers. Ignore that, that's just cruft from a mistake I made earlier, because it saves time, so you don't have to make the mistake during the talk. I find that very helpful. And then if we go here, you can see that we have a link to open the Redoc docs. And Redoc this is an open source project, and it generates not SwaggerUI, it generates actual documentation. This is a statically generated page. It's some HTML and some JavaScript, and you give it a reference to where your OpenAPI.yaml file is, and then it just generates all of this information. And it's really, really helpful. You know, down the side here, we say, oh, you can do get/read books, and we've got a response sample here, and I can copy that, and that's application JSON, and I can see what the payload is for this, and all sorts of other cool stuff. I've got response samples, and I can expand everything, so I can expand this title out here. And this is all these examples are all being pulled from my handcrafted OpenAPI.yaml file, which is why they make sense. And they're not just random strings and numbers and dates and everything else. And so that's really nice. It's quite nice. I thought that was the best thing ever until I saw this. So this is Elements. Similar sort of deal. It seems to be built on web components. And I just like the idea of using something in production that uses web components, because I haven't had much chance to do that. So this is describing the Dundat API. And in here, so we immediately see this uses implicit OAuth flow, and you can use this to go and get an authorization token for it. And then if I go into books and I go to get list of completed books, not only does it demonstrate the thing here and it says, okay, so you got a request, the security on the request is OAuth 2.0, so you need a token. Here are the responses. The body is going to be an array of this object with an ID, a title, and a finished at. But then over on the side here, we've got a kind of send API request. That won't actually work because 123 is not a valid bearer token. But look underneath that. Request sample, C# HTTP client. So what redoc does is it shows you the curl command to call the API. What Elements does, using a plugin from somebody else, is it gives you request samples for how to make this request using any of these languages. And actually for C#, it'll show you how to do it using HTTP client or REST # if you're a fan of REST #. But if you want to do this from JavaScript, then it'll show you how to use it, fetch, XML HTTP request. So if you want to support older browsers, there you go, that's how you do that. Oh, look, there's a copy button. It's like Stack Overflow just for your API, so people can just copy and paste stuff. Now, obviously, for a lot of languages, NSwag will generate you a C# client, a strongly typed C# client from an OpenAPI specification. So that's there as well. So this is just another alternative way that you can approach this. And the key thing here is that the URL for this page is rendlelabs.github.io/ldnug2020. This is from a different repo. NDC LDN 2023. Yeah, it's the same. I tried this talk out first at London.NET user group, which, by the way, if you live in London, you should really sign up for their mailing list and go along. They have some fantastic events. So yes, it's in the GitHub repo. The application isn't running anywhere. I haven't got the application running in Azure App Services or a Kubernetes cluster or anything like that, but the docs are still available. And the docs are generated. If we go over to the GitHub repo here, and oh yeah, no, that's not the GitHub repo. Where's the GitHub repo gone? God damn it. NDC LDN 2023. Okay, so we have our done that, and we have our OpenAPI file in here, and then if we go back up to here, we can go into GitHub workflows, and we can go into main.yaml here. Actually, let me bring this up in VS Code. No. There we go. Right, workflows, main.yaml. It's not a huge, great, complicated thing. So build and deploy pages. We have on the branch main steps, checkout, obviously, install and build. So we're going to use Dundat OpenAPI as our working directory. That's where our YAML file is, and our directories below that with responses and examples and schemas and whatever else. And then we run npx, which is the magic npm thing that installs something from npm and then runs it immediately. Redocly/CLI bundle. This is the thing that turns a whole selection of OpenAPI.yaml and JSON files and mungs them all together into a single YAML or JSON file. And then that will produce dist/dundat/OpenAPI. And then I use James Ives's GitHub pages deploy action to push that folder dist onto my GH pages branch, which then makes it available as a page, makes the HTML pages available in there. And that's it. That's the whole thing. So the dist folder here, where are we gone? So yeah, this is the stuff that's already in that dist folder. So we have elements.html. So that elements page, that really, really nice thing with all the code samples and everything else down the side, the C# code sample and everything else. I don't even need to scroll that. That doesn't scroll. That's it. That's that whole page. That, plus that YAML file that I put a little bit of effort into writing and creating examples in and all that sort of thing. That's the whole thing. And it just generates that lovely thing. And there's an export thing up at the top right of that, which will literally dump the entire thing out as pure static HTML. So you could email it to somebody and they could just open it on their computer without needing to be able to see the YAML file. It's also got the redoc HTML. It's a little bit more involved, but really not very much. That's just a link to the latest redocly thing on there. And we have the OpenAPI YAML file, which gets overwritten as part of that build step. So yeah, now I have the standard is maintained in my GitHub repository. The developers have all agreed that that's it. It's source controlled. We have revisions. We have code reviews when someone wants to make a change to the specification. But now we can also, inside the GitHub repo, generate redocly or elements HTML. And we could put SwaggerUI in there as well if we wanted to. But we don't. So yes. So at the start, yeah, we're doing good. I mentioned Moonwalk, OpenAPI 4.0. So this is, there's a bunch of people at Microsoft working on this, but it's an OpenAPI working group. There's kind of like a standards body for this. There are some issues with the OpenAPI format. The main one is when you think about the structure, you have paths, and then you have a path, and then below that you have the operations, and the name of each operation is the HTTP method that you use, get, put, post, delete, which does not account for the fact that actually sometimes API endpoints are polymorphic. And so you might have an API endpoint where you can post stuff, and you could post, I could make it so that I had a single endpoint, done that, and you post something to it, and then it uses the structure of the JSON document to work out what it is you've done and updates the thing appropriately. And that might be quite nice. But I can't describe that in OpenAPI 3.0 because it just has a single post operation. So one of the things Moonwalk does, one of the big things Moonwalk does, is it changes that. And so under paths, we have users, so that's just the path there. And then we have requests, and then we have initialize user. So we've switched that around. That would previously, we'd have had operation ID : initialize user. Instead of doing that, we actually use initialize user as the name of the operation, and then below that, we specify that the method is put. So this means we can have multiple operations that use the same HTTP method. So that's quite nice. And there are a few other things that they've just tidied things up and made them easier for human beings to read and write. And that sort of thing. And the other big change is that the JSON schema in Moonwalk is actually JSON schema. So they have not subsetted and then slightly supersetted JSON schema. They've just gone, if it's JSON schema, it's OpenAPI 4.0 schema as well. Apart from that, things are pretty much the same. It's not a huge change. They haven't changed things for the point of changing things. So that is, there's a GitHub repo for that, github.com/OAI/Moonwalk. You can see some more examples in there. You can raise issues. They've got a discussion section, so you can bike shed to your heart's content and talk about stuff. So, tools. SwaggerUI. You're aware of SwaggerUI. That's the thing that Swashbuckle and NSwag throw in there for you. We also have Redoc, which is one of the options for documentation, and also the thing that provides that command line interface where you can bundle YAML files and everything else. There's a thing called Widdershins, which I put up there because there's a thing called Widdershins. I have no idea exactly what. It's very complicated. It's like latex or something. But one of the things, so somewhere inside Widdershins, there's a way of taking an OpenAPI spec and just turning it into Markdown, which I thought would save people at my organization an awful lot of time, even if they have to run the bloody Azure function and then go and get the YAML file from that and then punch it through Widdershins and then dump that thing into their thing there. And elements at the bottom, that's my current favorite for documentation and stuff. And then we have plugins. So if you're using VS Code for your thing, then OpenAPI brackets Swagger, close brackets editor, is the sort of standard, that's the best plugin for Visual Studio Code. There are several, but this one is maintained by 42 Crunch. It's an inbound marketing tool, so they do actually maintain it and put some effort into it, and it works very nicely. If you use JetBrains Rider, then OpenAPI, it's a plugin, but it's one of those plugins that's automatically installed. And you get really nice things in JetBrains Rider. I'll show you some of that in a second. If you use Visual Studio, don't. So to be completely clear there, by all means use it for maintaining and editing and creating and doing everything else and right-click publishing your ASP.NET Core applications and your by all means use it for that. It's fantastic. But if you want to edit an OpenAPI file manually, use Visual Studio Code, unless you already have Rider, in which case use Rider. It's very nice. And then bundling. So this is that important step. If you've broken your spec down into multiple files to make it easier to manage and do pull requests on and everything else, then Redocly, you do npm ig Redocly, and then it just becomes available. And I am aware that there is a sort of pushback against why do I have to install Node when I'm a .NET developer, and I feel you. And I completely agree with you. That is actually why I am writing my own bundler. Speaking of things that I'm writing, it's quite a lot, actually. So, Rendle Labs OpenAPI.web, that's already up on NuGet. That works. And I'll just show you very quickly what that looks like in code. So here is my done.dat API solution. So I've commented out the stuff that .NET New put in there for me that I don't want. So I've taken out this whole bit about builder environment is development, add endpoints API Explorer. That's the API reflection tool that Swashbuckle uses to generate OpenAPI. Add SwaggerGen, we can take that out of there as well. We've just got various bits and pieces there. And then in our request pipeline, we've got the environment.isDevelopment. We can take out use Swagger and use SwaggerUI. Those came from Swashbuckle. And instead, we can use app.useStaticOpenAPI. That's my thing. There we go, it's a bit bigger. So yes, you can either sort of make sure that your OpenAPI.yaml file is copied to your folder along with everything else, and then you can specify a path through it, or you can embed it as an embedded resource in the assembly. So it's just a single DLL file, and then this will pull it out as a manifest resource stream. We specify the version in there, the UI path prefix, the JSON path, the YAML path. It will generate both the JSON file and the YAML file. So we give it a YAML file, but it'll turn that into JSON if something really wants JSON. And then I want to put elements documentation on here as well, so I tell it the path to use for elements. There's a readocly. If you prefer readocly for some reason, you can specify that as well. That returns a standard API endpoint convention builder, which means you can put allow anonymous and all the other things on there. You can cache it, you can apply cache headers to it and all this sort of stuff. So it's a lot more configurable than what Swashbuckle throws out. And I can show you that running. So here's the SwaggerUI. This is being generated. That is running. That came out of there. That's showing you the JSON. And if I go to v1/docs, that generates the elements HTML. So it's on the application and it's in the GitHub repository. It's exactly the same because it's exactly the same OpenAPI file because it's being bundled using the same tool and published or embedded using the same tool on both build processes. So that's there. That already works. I'm using that in a couple of things, and please do go ahead and use it. Things I'm working on, the bundler is it's actually pretty much done. I just need to actually wrap it in a .NET command line tool and publish that. Analyzers, so this goes the other way around. And one of the things that I get pushback on this is people say, but if you're generating the OpenAPI stuff from your application, then you know it's right. You know that it's right. And you go, no, you don't know it's right. You just know it's the same. You could very well be wrong in 2 places automatically, saving you 50% of the effort of being wrong. So yeah, but this is a good point. At least you know that the OpenAPI that is being put out matches what the API is actually doing, even if that is the wrong thing. I would argue that this is a false sense of security. I'm working on analyzers where you say, hey, here's the OpenAPI file, and it will analyze your minimal API or your controllers or your Azure functions, and it will actually tell you, hey, the spec says that this returns a 404, but I can't see anywhere in your code that you're returning a 404 response. So I'm going to put a little squiggle here that says you're not returning a 404. And raise a warning with a code, and you can then mark that warning as an error and make it impossible for somebody to push something through a CI build if the code they've written doesn't do what the spec says it does. So that'll be fun. OpenAPI.test is an attempt to replace horrible spec flow gherkin-style things. If you can describe your API in YAML, why can't you write the tests for your API in YAML? So you can put request and then an expected response, and this currently just automatically generates XUnit tests at runtime and runs them using theories. And then CodeGen is the last bit, and CodeGen, remember I mentioned gRPC and protobuf earlier on. What gRPC generates when you do a service is a base class that has virtual methods for all the things you said it would do, and they're not abstract, they're virtual. You don't have to override them, and if you don't override it, and then somebody calls it, it will throw an RPC exception with a status code that says not implemented. So it's basically throw new not implemented exception. HTTP has a not implemented exception. So what the CodeGen thing does is it generates model classes, and it generates a base class with these virtual methods. It doesn't generate a controller, it doesn't generate a minimal API, it doesn't generate these things. It generates its own sort of base class, which you can then inherit from, implement. It's got convenience things in there. It will generate automatic result codes, but only for the things that you specified in your OpenAPI YAML file. If you're going, why can't I return not found? It's because it's not in the fucking spec. And then you do that in a class library, and then you create a web API project, and it'll hook it up using minimal API. Or you can create an Azure Functions project, and it'll hook it up using Azure Functions. And then that's going to be pluggable, so if someone wants to come along and contribute an extension to it, it could generate something that hooks it up to AWS Lambda or Google's app platform, or whatever that might be. So that one I'm kind of quite excited about because I think that's the point where I can go, here, there you go, this is the right way round to do it. Write the contract, generate the code from the contract, and then you know that the thing matches because you're overriding a method and you don't have the ability to change it. So, there we go. Have I convinced anybody to at least think about this? Show of hands. Oh, fantastic. Yes. Good people. I love you all. Go out into the world and spread the poison. So, yes. References, openapis.org, swagger.io, that's Bugbear, the people who originally started all of this. OpenAPI.tools is a very helpful list of things. There's Async API, which I suspect Ian would be interested in, which is somebody attempting to apply all of this to messaging. So you have producers and consumers and things, and you can describe the messages and all that sort of stuff. The code for this, well, it is at LDNUG 2022, but it's also at NDC LDN 2023. And that actually is the end of the slideshow. Click to exit, everybody go home. Is anybody coming to PubConf? Yes, I'm terrified. Thank you very much for coming. I hope you've enjoyed this. I hope you've enjoyed the conference. And I hope that I will see you all again next year, if not before. Take care. Bye.